Hey everybody, we are going to attempt 11.3 today. Now this lesson is on simplifying radicals. Sometimes you're given a radical that you could approximate with a calculator, but other times you're told to simplify, and what you're trying to do is pull out from underneath the radical any perfect square factors, right? And then take the square root of that part. Now you did this in pre-algebra, hopefully you remember it, but let's say that we have a number like radical 75, okay? Now again, I could approximate. If you're told to approximate, use your calculator. If you're told to simplify, you would want to simplify that by trying to break 75 into factors whereby one of them is a perfect square. So a long time ago when I made you memorize the perfect squares like 1, 4, 9, 16, 25, 36, and so on, I had a reason, okay? Many reasons, but one of them was I knew you would have to learn how to simplify radicals. So most of you can look at that and go, oh, 25, that's a factor of 75. So you would rewrite that as 25 times 3, right? And most of you, if you saw radical 25, you know what that is, right? It's 5. Okay, but this radical 3 is still stuck underneath there. So you write radical 3. Okay, so the book will show you a little different method. You can certainly read through the book and do it their way. I have found this to be helpful. When I write the perfect square factor first, I can quickly see that that comes out. And then whatever's stuck underneath, you just still keep with the radical. So now I have simplified radical 75. All right, so the first example, you'll see it's radical 18. And of course, I would rewrite that as 9 times 2. So I know that the square root of 9 is 3, but radical 2 stays underneath. Now, some people tend to get these mixed up. They'll say something like 2 and then radical 3. So that's why I'm going to suggest that you write it with the perfect square factor first, and then you think about that coming out and what's left underneath the radical. And sometimes that helps you to do it correctly. All right, so then you have on example 2, the next page, I'm on page 492, you have radical 48t. Okay, well, does 48 have perfect square factors? Yes, it does. Now, it has 8 and 48 is 8 times 6, but that's not going to help me. That's not a perfect square. 16 times 3, that's the perfect square factor. And then, of course, the t. All right, so what comes out? Well, the square root of 16 is 4. But what's left underneath? The 3 and the t. So 4 radical 3t. So sometimes you'll have a letter left under there, a variable, and that's okay. Okay, you can't pull it out if it's not squared. All right, the next example, we have 72x squared. All right, well, 72. Now, I know that's 8 times 9, but if I pulled out, right, the square root of 9 as 3, radical 8 that's still underneath has perfect square factors. So I'd have to do it in 2 steps, and I'd prefer not to. So what you want to do is think about the largest perfect square factor of 72, which is 36. So I'm going to write 72 as 36 times 2, t squared, or x squared, sorry. Okay, so radical 36, 6 comes out. Now what about the square root of x squared? Well, x would come out, wouldn't it? Because what is it saying? The square root of x times x. So if I have 2 of them, one of them comes out. So anytime there's an even exponent, you take half of those factors out. All right, so that takes care of the 36, the x squared. Oh goodness, pen. And then the radical 2 is stuck underneath there. Now, some people, you'll see the book tends to write it like this, the x coming last, okay? So you can switch the order. All right? Now the next one, we have square root of 3x squared plus 6x plus 3. Oh boy, trinomials again, your favorite things. Okay, so your strategy is, first of all, to try to factor this. Now obviously, 3 goes into all of these terms, doesn't it? So 3, and then that gives me x squared plus 2x plus 1. Hopefully all of you know that, just factoring the 3 out of all 3 terms. Now, this, sure enough, is a binomial square, right? This is a trinomial square, so it factors into the same binomial. So under here is really x plus 1, x plus 1. So it's underneath the radical. So I factored this trinomial into these two binomials. So remember, that's the same thing as saying x plus 1 quantity squared, right? So if anything is squared, that anything comes out. And I might want to put parentheses on that. But then the square root of 3 is still stuck underneath there. Okay? So this is our final answer for example 4. All right, so I'm going to want you to stop the video, do your practice, and I'll be putting it up on the board. Do them on your own, please. And once you're finished, you can start the video back up, okay? Pen. I think the pen has the coronavirus. Okay, so let's try this. As you see, I took 32, I broke it into 16 by 2. That comes out as 4, radical 2. Okay, B was easy. Radical 25 is 5, radical x squared is x. 60 I rewrote as 4 times 15. Square root of 4 is 2. But these things are not perfect squares. They don't have any factors that are, so they stay under the radical. Okay, 45 x squared I rewrote as 9 times 5 times x squared. So this comes out as a 3. X squared comes out as x, and radical 5 stays under. All right, for E, I factored a 7 out of the trinomial that you're given. So I got x squared minus 2x plus 1. This is a trinomial square that factors into x minus 1, x minus 1. So I wrote it quantity squared. So if I have a square of something, that something comes out, but the radical 7 stays underneath. All right, next part, we have the square root of x to the 6th. Okay, so you guys see what this is? It's like saying this is x squared times x squared times x squared, right? 2 plus 4, 2 plus 2 plus 2 would be 6. So this would be x, this would be x, and this would be x. So I have x to the 3rd. So the shortcut, if that's even, take half. So So if you have the square root of y to the 10th, what comes out? Y to the 5th. Okay, it's that easy. All right. Now, what if it isn't even? Okay, so what if you have x to the 7th? Well, think about what you have in this case. This is like saying x squared times x squared times x squared times x, right? There's an implied 1. Okay, so you've got 2, 4, 6, 7. Okay, so 1, 2, 3 come out with radical x being left under. All right? So you can kind of say, well, what's the closest even number to that? 6. Take half of 6, and 1's left over. That's how the shortcut works. All right, so let's do the practice, or the F, G, H, and I. Stop the video, do your own work, and then check with mine. Okay, so for F, just take half of 8, 4, easy. Now just because this is a binomial, it's okay. I'm not gonna write it 14 times, I'm just gonna take half of them out. Square root of something to the 14th would be that something to the 7th. Okay, t to the 15th is like saying t to the 14 plus 1 more. So 7 come out, but 1's left under. A to the 25 is like saying 24 and 1. So 12 come out, 1's left under. All right, so not too shabby here, pretty easy. So I want you today to do page 493, 1, 2, oh goodness. This pen is going to just drive me nuts. Okie dokie, that's today's lesson. Have fun.